The following content is provided under a Creative Commons license. Your support will help MIT OpenCourseware continue to offer high-quality educational resources for free. To make a donation or view additional materials from hundreds of MIT courses, visit MIT OpenCourseware at ocw.mit.edu.
Alright, thanks for coming, you guys. My name is Bus Leonard.
I'm Carter.
I'm Brianna.
And Rosser's not here right now, and our team lead is Ken. And we're working on an OJ sealer for a community in Nicaragua. We were partnered with the NGO ASO Phoenix, which is a organization that does rural sustainable development projects with multiple communities in Nicaragua, and they do projects such that promote clean water, electricity, income generation, and also educational projects that help the community be healthy. So our project centers around the community El Roblar that we visited while we were down there, and they have a large orange harvest crop that they get, and there's no market for the oranges during the harvest season because everybody's harvesting oranges. So the idea is to create a way for them to sell the oranges or a product from the oranges in the off season to generate income. And they were introduced a pasteurization process to preserve the orange juice by ASO Phoenix and through the University of Managua. So that process is in place, and we are trying to develop a way for them to seal a plastic bag in order to preserve the juice. And this is actually stemming off of a project that was started during last year's D-Lab Energy class. And you see that project pictured at the bottom here. And our specifications that we want to achieve with our project is to have the device be able to run off 120 volts of AC current, and the seal should be done while removing the air from the bag, so there's no air in the bag to prevent spoiling of the juice after it's sealed before it's sold. And we also want to create and maintain the durable, user-friendly interface that was began with last year's project.
So this is a bigger picture of last year's project, and it sealed bags nicely and all, but there's several areas that we feel need improving on before it can actually really be used. The first one is the power supply. Between last year and this year, the community that we're working in got rid of all their 12-volt batteries like that because they got a micro hydro grid, and so now they're running on 120 AC, so we need to make it actually be able to run on the power that they have. I mentioned removing all the air from the bags. The preservation process isn't very strong, so it's a key part of making sure the orange juice stays good. The wide, flat surface that they're sealing on here makes it very, very difficult to do that. So we wanted to improve that as well. And then when we talk about comfort in using it, the light that indicated whether something is hot or not was right about here, and you would use it from the other side. It was very difficult to see. There's a latch that's really difficult to open, and trying to get the bags to get all the air out because of the wide flat surface was also very difficult. And the control, the timing circuit there, that they used an out-of-the-box timing circuit, mainly I think because of limited time, that cost $26, so we're also designing a simplified timing circuit built out of just components that is only going to be a couple dollars.
So we wanted to first go into experimentation and see what needed to be done to, get a good seal on a bag. So we first started off with what type of plastic do we need. We basically tested. We got some plastic from Nicaragua and we brought it back, and it turned out to be 25 thousandths of an inch. So we're testing with 25 thousandths of an inch and 45 thousandths of an inch. That because there's various plastics there, and so we wanted to test with multiple types of plastic to accommodate that. In addition to that, we wanted to see what temperature was needed to fully seal plastic. So we used the standard impulse, or the industry standard, which is the impulse sealer, to seal a bag, and we used a thermocouple to determine the temperature. We got a temperature of about 195 Celsius, and you can see gets a good seal like this. Let me pass this around if you want. The water should be orange juice, but yeah. So we got 195 Celsius. That's the temperature we need to hit. And in addition to the temperature, another factor is pressure. How much force do you need to put down on a nichrome wire to get a good seal? So we used a force plate sensor and push down on it. We got about 56 newtons, which translates to about 169 kilopascals on the nichrome wire. And you can see over here if you don't apply enough pressure, you get a sort of like a perforated line where there's seals, like there's a lot of gaps in between the seals. So this is not a good seal because there wasn't enough pressure, although the time was perfect. For this, with a 6 kilogram weight, you got a good solid seal on the bag. Everything looks good. Water did not leak, and that is ideal. In terms of timing, we also want to make sure you apply the right amount of time, or else it melts. The plastic will melt. So what we did was we had a standard weight. We applied it to our rig and tested with a constant voltage, different timing. We ran the device for a certain amount of time and then increased it slowly. So you can see as you increase more time, this wasn't enough pressure because you see the dimples, but you can see over time that it's a very small seal to one that's melted. And so with various weights and various voltages and varying the time, we got figured out exactly what we need. So in terms of power and voltage, I'll pass it off to Brianna.
So before I get into our different tests of power and voltage, you might notice that it says like 5 volts, 10 volts, 12 volts, but we were talking about 120 volts AC. This is because we decided that the best way to run something off the wall power is actually just to buy an adapter and plug it in and convert it to 12 volts DC. Running something off the wall makes it very difficult to have our timing circuit work. We'll probably have to rectify that into DC anyway. The 120 volts with our nichrome, that's like a 4 ohm resistor, would have to add either more resistors that would do nothing for the heating and be expensive because they'd have to be big power resistors, or lots more nichrome wire, which would again be expensive. If we built our own adapter, the price came out to just about the same as what 12 volt 384 amp adapters are selling for, and it would be more complicated and harder to replace and such. So it turns out that the best solution to running it off the wall is just to buy an adapter and run it off the 12 volt set anyways. So we did tests with power and voltage, or power controlled by what voltage we were putting across a resistor, and the time that we left it on for. These are just a couple samples there. You can see at 5 volts, even when we were doing it for a minute, we didn't get hot enough to melt the bag at all. I know the pictures aren't really great, but bear with us. At 10 volts, we had a good seal in just 20 seconds, and at 12 volts, by the time it was 14 seconds, we were already sealing it too much. So this was giving us a good idea of our trade-offs between how much power we're using, what range of powers and times we can use. I think we did get a good seal of the 12 volts at about like 8 or 10 seconds, but didn't really have a at all visible picture of that to show you.
So that was the experimentation that we did, and we wanted to use this results into our design. So when we designed our product, we wanted to take two things into mind: functionality and usability. The thing about functionality is we want the users to be looking down on the product so they can use it on a table, and they also want a nice latch system. So as you can see over here, we have an angled product, and since it's angled, you can look down on it, use it easily. I should be taller, but yeah. And with this angled plane, you can have the bag hanging down as such, so that the liquid will be in the bag, and that you can get a good airtight seal here.
And then another bonus is that the excess juice that we're sealing through juice in order to get an airtight seal. the extra juice you can just let run off after you make this seal. You can have a pot sitting right here to catch the excess juice. So that's another. And there are springs in this arm that allow you, once we have a latch system, that will keep the same force for every seal. So you'll know that you have enough force, and that given the timing circuit, it'll run for the same amount of time, so the seals will all be the same. And then more on the latch system. The springs also provide some give that will allow this to be compressed a little bit more than the necessary force for a seal. So we can just have a simple rotating thing out of sheet metal, something that's readily available in Nicaragua. And then you can slide it over like the picture, and then when you want it off, you can press down, slide it back off, and you'll be ready to go.
So I guess some future things that we need to work on. One thing would be combining the ergonomics, the usability of this product in addition to the functionality. We were doing a sample test on basically just 2 pieces of wood, testing putting weight on top, and so we need to add a nichrome wire onto the base of this so that we can actually seal bags with this design. In addition to that, we need to finalize the circuitry and design a housing device for the electronics that we would be placing on the side. In addition to that, once we have this completed, basically just get users to test it, make sure it's intuitive, easy to use, and a great product overall. We'd like to thank Ken, Amy, Amit, D-Lab overall, and our community partner, also Phoenix. Are there any questions?
So, you're sealing through juice right now. Are you testing that by sealing through water?
Yes.
Can you seal through pulp?
That's a good question.
We have yet to test that.
Okay. It's probably time to buy some lunch juice.
And yeah, I would buy
like the super extra pulpy version, and then throw some like sticks and rocks into it.
Yeah.
Good measure.
and at one point it would be worth it to test, like actually squeeze your own juice, because it's not that hard to make a bit.
Any other questions?
How important is the latch mechanism? Like, why can't you just hold it while it's
We wanted it to be able to, I guess, be easily used by one person ideally. So if they we're not sure that this, like there could be cases if they're filling like liter bags or 2-liter bags of juice, if they're selling it to restaurants for kind of like wholesale, like to restaurants, this force pressing down might not be enough to hold the bag. So they might need to be holding the bag, pressing a button. So you want to be able to do one thing at a time with your free hand.
In addition to that, you also want to have a constant force for each seal. So there can be variable forces if you like push harder or less than each time. Where
I'm gonna say that it's also might be easy for these guys to remember like how much force they didn't always put enough force on it. But when I was doing some tests, I wasn't always getting enough force on there. And the people who are doing this are women and girls, so it's like even like 9, 10, 12-year-old girls being able to latch it down prevents from having to hold all the pressure there all the time.
Is the current device being used? Or is it here?
It's
half of it attached to that.
It's the last one.
No, this is a new arm. We left the last year's model in Nicaragua with House of Phoenix,
Is it being used?
and it works off a 12-volt battery. I'm not sure if it's being used in another community.
we delivered it last month.
It's not orange juice season at the moment, so exactly right now it's not being used. I don't know whether they will take it out to the community to use it when it becomes orange
Last
season.
year's project also did not have the specification to remove the air, so using that while removing the air is also more
So
difficult.
The feedback that you have is based on is from the field or from your own?
From the
operation?
field, from our spring break trip down to Nicaragua, and fact finding there in El Roblar.
With that one?
With
Yep.
yeah.
Do you have any, can you show pictures of that testing?
Yeah, we have pictures. Sure.
Right, I missed it.
No. Thank you. Pull
you're doing, one thing that you might want to think about is since you're trying to create sort of at least notionally sterile stuff, you might want to start, it might be time to start thinking about segregating this thing into the stuff you have to keep clean and the stuff you don't have to keep clean. Because like having to reach over with your, you know, your sterile hand that's in all the juice and in all the stuff you're trying to reclaim, and like reach over and hit the button on the top of the timer is going to become a drag if that button somehow has to stay clean. Like if you can give them things like foot pedals and elbow switches and, you know, stuff so that, you know, just to think about the process and like how you're going to keep the clean stuff clean and sort of minimize the amount of stuff you actually have to keep sterile will make the process go easier.
I probably missed it, but what is the price point in
There aren't devices that use low power like this. I'm not sure what the price point for the impulse sealer is, but running it off batteries or the microhydrogrid, you can't use that. It uses more power than there's a limit to the amount of power that any like device they've run off the microhydrogrid that ASA Phoenix has installed is allowed to draw.
So also Phoenix doesn't allow use of irons or like hair dryers or hair straighteners or anything that's heavy power intensive like that.
When we compare what we have to the design that was made last year, I think we're probably about $10 less, which not if you not include a battery, I think that makes us around $40 instead of around $50. Which
So it's not
no, it instead of sealing our slide about the commercial one, it used some large amount of power for about half a second. This will use like 30 watts for more like 10 seconds.
So these are our photos working in the field in the house we stayed in El Roblar. A group of about 8 to 10 of the women of the town came and we gave a demonstration of how it works. Roll through. So this is, we found out that there were no 12-volt batteries, so we strung up a bunch of AA and AAA batteries just to be able to do the demonstration. So
we got like somewhere between like 6 and 10 bags of that for the batteries.
Yeah.
Pictures of them.
So this is the process. Then they actually got to seal a few bags themselves. And let me know if you have any questions as we're going through.
Do you have any sense about like a minimally acceptable amount of air in this thing?
We heard from the community partners that they didn't want any air.
Okay, yeah, sure.
So, in terms of like room for error, we're not sure. We don't know.
Because I wonder if there's a correlation between like the size of that bar that it's hanging off of and how much air, you know, like presumably if you make a really sharp edge and.
So ideally, we're gonna have the nitrile wire as close to the edge as possible to get it as clean a seal as possible. Because the further in it is, the more overlap there is. So there's gonna be potentially more air. Because it's easier to get like clamp it like this versus on top, but.
And that's actually the last. Well, no.
Yeah.
Tried to run it off solar as well, but this is getting away from the presentation more.
So how many bags have you guys sealed over the course of the semester?
Oh, including the testing, where we were
Have you
just
ever
doing.
sat down and had, you know, 5 gallons worth of orange juice or 5 gallons worth of water and 100 bags that you want to fill?
We usually
Have you
just-
done it in a real process, or is it just a single one-off?
So-
One off every now and then. We've been sealing bags this size of at least 20 or so.
But that was with our kind of works-like model, so we haven't combined the sealer with this ergonomic application of it yet to have something that.
Are those bags, the individual bags, locally available, or do you get it in a long tube?
They get in a long tube.
Okay.
and we have about 6 feet of that tube here.
Have you thought about how that could change the process a little bit? If you can fill the whole tube with orange juice.
Yeah.
Seal,
and then
cut,
just
cut.
cut. Yep.
Double seal each time.
Mhm.
We have the long tube, and that's for like the individual size servings. We aren't sure that would always be what they would get, especially if they're like 1 or 2 liter bags. So we wanted something. I think we were trying to go a little more flexible rather than specifically for that would only be an advantage with the long tube.
You can still use that process.
Right. And yeah, or even if you had a little extra add-on to hold to support part of the tube where they're filling that.
That's actually something in the middle where all you have filled above what you're sealing is like another half a bag's worth of orange juice or something. So you don't have to hold, like if you're filling 1 liter bags, you don't want to have to hold 50 pounds of bags above this thing. But if you have it sort of as a continuous process, so you've only got like a half a bag's worth of stuff supported above, no matter what size the bag is, and then you keep filling it, once you've made that last seal, then it makes the support problems a little bit easier. It might be too late to start thinking about that.
Once the orange juice is sealed, does it need refrigeration?
No.
No, they have
As long as there's no air.
a pasteurization process that comes before, and as long as there's no air.
Is there a standard for the size of bubble that can remain, or does it have to be absolutely no air?
As Steve asked, we were not sure. Yeah.
You guys were gonna look into that. Did you make any progress there?
I think the most answer we got
they
was
said
that
was
yes,
no
the air
air.
needs to be removed. There needs to be no air, and whether that's like overstating the requirement or actually there really actually needs to be no air, that's where we're unsure. I think. So we're making our goal be there is actually no air.
Have you started testing to see if you can actually successfully seal with 0 air or 0 noticeable air?
I think we did one with our flat one that wasn't even that we had no air in. Yeah.
How crazy is their pasteurization process? How would
Yeah.
just like throw it in a pot, boil it for 10 minutes, and then put it in the bag?
Some
Similar.
citric acid, yeah.
Yeah.
Oh, so I'll bet it depends a lot more on keeping the clean room clean than on how much air is in the bag. Because there's air in a bottle of Sunny Delight. There's air at the top of, there's air at the top of a bag of a jar of pickles. There's, if it's pasteurized and it's highly acid, then you're trying to, what's left that you're trying to get rid of with botulism, but air doesn't help that. I don't know. It's a, yeah. I tried to find
Well,
a canning book.
it'd be good to both be able to answer that and also know, like, even if you have the answer that air is okay, if they are convinced that air is not okay, that may be a knockout blow. And so practicing to make sure the ergonomics and whatever your process are set up such that you can actually ensure that most of the time you're getting a bag with no air visible, I think would be good to practice that a bunch.
I heard you guys talk about housing electronics. Have you guys, I'm not sure if I missed it, but are you planning on keeping sort of surface as it is with the wood? I'm just wondering if the wood gets wet.
It probably wouldn't be directly wood like that. This was an earlier model. We've got it covered in plastic. Probably where the way we're going to go. Last year's was painted or lacquered or both. So there'd definitely be some kind of more wipe downable surface.
Yeah, wood's not the end of the world. And as long as it, what kills wood is going wet, dry, wet, dry, wet, dry, wet, dry over and over and over again. But if you're going to run it all day long wet, it's not the end of the world. Wooden cutting boards are cleanable. You just might not want to make it out of something. It's nice to be able to make the surfaces flat so you can clean them. So like really soft pine or nick and harbor stuff, but
harder wood would probably be okay.
I think one of their main concerns also was capturing the overflow juice.
Yeah.
In that case, you want a very sterile surface, or as clean as you can get. And if you have an extra 8 inches off your roll of plastic or 6 inches off your roll of plastic that you can just wrap that bottom portion with, that's like kind of your runoff shape. Then you don't actually have to worry about cleaning your wood as much as you would have.
It's also advice for them the overflow to like soak into the device rather than being reclaimed.
Only the first little bit will soak.
Yeah.
Okay, thanks you guys.
Hi, we're the charcoal group. I'm Vivian.
I'm Jessica.
And I'm Kurt.
And our project mentors are Amelia, raise your hand, and Steve over there. Okay. So first, okay. Our main Our main motivation for our project stems from the work we did with a Nicaraguan-based NGO called Group of Phoenix, and more specifically, we worked with a cooperative called the Mujeres Solares, which is the Solar Women. Basically, we introduced the idea of D-Lab's agro-waste charcoal, and for those of you who aren't familiar with it, it's basically a process of making charcoal out of agro-waste or biomass instead of wood. So, you reduce deforestation and it burns a lot cleaner. We really wanted to improve this process so that the women would feel more comfortable integrating this into their everyday lives or possibly using this as a business activity for them. Right now there is a general discomfort with the process, and Jess can talk to you a little bit more about those specifics.
So what was really unique to our group was that we had the language to get the direct feedback from the women. So we didn't have to go through a third person. Instead, I was able to interpret exactly what they were saying. And I've highlighted here that the biggest issue for them today is still covering the barrel because they cannot bathe afterwards after dealing with so much heat of the barrel. They say that the heat is too intensive for them, and then they would bathe with cold water and then they would get sick afterwards. So that's the biggest gap for them right now. Even when we discussed the different project ideas that we had to make the charcoal process better, they still brought us back to, we really want you to work on the barrel, do something so that it doesn't feel so high.
Sorry, do you want to run through the current process? So we're going to show you a video of the women doing a charcoal burn there.
Well, I can't fast forward, but this is the third charcoal burn that the women are doing by themselves. We trained them, and then we had them do the first 2 by themselves. They were successful. This is the third one, and you can see that even in the third trial, there's still some uncoordination in the barrel sealing. This is a current design where the barrel sits on top of the bricks, and you have to tilt and kick, and sometimes kick too much. And so what we can see here are the main pain points of the process, which are, I'll stop that right now, which are the heat intensity of the process, which is what they've identified, and of course the safety issue. And we realized that we need to address these 2 concerns while still meeting the same quality of a charcoal burn.
Great. So in order to meet these criteria that Jess just highlighted, our design submerges the bricks on which the barrel sits into the ground. And so basically what we've done here, I can show you on our model here. This is one of the ideas of the charcoal burn is that it uses commonly available materials like a oil drum. So I've used a natty ice can here too, in the same spirit. So instead of sitting on top of the ground, it now sits on bricks that are submerged into holes. And so the design is pretty simple. There is a dugout hole. There are 6 bricks that line 3 channels, which allow for airflow. In this space right here, the ground and the barrel form a seal, so the barrel does not move once it's been lit on fire. And we've calculated the airflow so that there is sufficient airflow through those channels into the holes that are at the bottom of the barrel, so that while it's burning, there's enough air. And so to work on sealing these channels, we've come up with these metal plates right here. So essentially, this is just sheet metal, and it has these handles on top, we call them, and they can be pushed in underneath the the 3 channels to seal them, and just with a little bit of sand, it forms a seal around the whole barrel. So eliminates the need for tilting the barrel, kicking out the bricks, and all of that. And we experimented with a number of shapes here at the top. So this is a semicircular. We also have like triangular shapes, and then various types of handles, which Jessica will go into in a second. So an overview of the benefits of this design compared to the existing portion of the process that we're trying to fit are, first, that it minimizes the heat exposure, because the flaming barrel is now in the ground, and there's no space for there's minimized space for this heat to come out. The second is that one person can seal the barrel rather than needing two, and we can show a video of that right now. Although so this is the entire process. And I'll talk through this. Third is that you can still light the barrel through the channels, and the barrel doesn't move once it's on fire and flaming. So as you can see, all Jessica's doing here is just pushing the plates in at a safe distance, and with minimal exposure to heat, basically.
And so, from our experiment, we were able to conclude what designs of sheet and handles were better equipped to meet our project attributes. We wanted to be able to steer the sheet, and the better design for that was a semicircular plate. In terms of maneuvering and being precise about where the sheet was going, the lipped handle, which is this one right here, allowed for the wood to come in and kind of fit right there, just enough to be able to maneuver the sheet into where we wanted it. The lifting potential of the lipped handle allowed us to sort of kick the sheet up a little bit if it ever got stuck right before the brick. And the 3 sheets worked equally as well to diminish the heat exposure and to lessen the time that it took to seal the barrel. Now, stepping back for a second, the sheet metal is only one of 3 barrel sealing alternatives that we're considering right now. The other 2 are inserting a brick into the channel of the dugout and covering the rest with sand. And the third is even simpler than that, just shoveling in or pouring in sand into the 3 holes. And of course, on the left, we have different sort of design specifications that we want this to meet, because it's part of the process that before was most heat intensive. You'll see there's an even spread right now of all the 3 designs. For example, the sheet metal is best in diminishing or in lessening the time that it takes to seal, but the sand could be done from farthest away if you just sort of take the sand and throw it into the barrel, throw it in along the side. But this is due to the metrics of the attributes, right? For example, the labor intensity. We consider that it's easier to seal the hole, but you do have to spend some time finding the sheet metal, which is readily available in Nicaragua, but you still have to make and manufacture the sheet metal with the handles. Only once, though.
So in our experiment, we concluded that our dugout was successful in addressing the need to reduce heat exposure. It channels all the heat down into the dugout instead of at the people working on it. We also were able to decrease a safety risk of the tip and kick method. Our sheet metal seals were also successful in creating a seal and resulting in a quality burn. We did get some really good carbonized material out of this burn, but there are definitely still improvements to be made. We can still work on the maneuverability and handling of these seals with the handles. And we can also work on adding a little more distance between the person and the barrel.
And so we're at our next steps, which are going to be to send the documented process of our new barrel design or charcoal making design to the women, and they're going to make a charcoal burn early next week. We're going to phone call them and talk to them directly. I'll talk to them directly and get their feedback on what the heat experience was, and see how they can explain that and whether it's better or worse. And finally, we're going to continue to look at improving the sheet metal design and seeing how we can manufacture it easier or how we can just get it a better design so we can maneuver it better. And finally, of course, we're here to incorporate your input. So, questions? Questions? Yes, Benji.
Have you been able to talk to them about the 3 different options of how to seal the holes, like in terms of like, would you rather make a plate or would you rather just like fill in dirt?
So no, the answer is no. Not about those 3 specific designs, but in our conversations with Lindsay, which is sort of their project coordinator or
our
liaison with the community, she says that she continues to say that the heat of it is the biggest exposure. So rather than have them do the test trials and all the experimentation of like which feels best or taking all this data that we've been taking, we try to get the data first and then submit our conclusive, recommendation to them, and then that's what they're going to do this week.
How are you actually going to communicate to them your idea? Do you need to describe the hole that you need to dig as well and that whole layout?
Yeah, right now, when you train a community to make a charcoal burn, there's a nifty document with diagrams that D-Lab has produced that tells them, how to make the holes or how to set up the bricks and all the process. And so we're going to do that. They've already been trained with that, and they have that document. We trained them over spring break. And so we're just going to sort of an addendum, an appendix to what the new process should be and how they should dig the hole and all that so they can do their charcoal burn next week.
And we have all the specifications for the hole based on like airflow, right? So that
how
we
wide
can
channel
send
should
them
be.
exactly. So we can send them very, very exact.
So they did fine before with the original document. They were able to go through it without any training or handhold.
No, we were there to train them personally. It's hard to communicate just with a document of step-by-step instructions, even though they're really well drafted, because they still have questions on. It's really about understanding the why of things. But now that they understand the why of things, like why it has to be sealed at a certain time, now it's a matter of just saying, instead of mounting the barrel on the bricks, instead make a hole, insert bricks, and put the barrel on top.
Okay. My expectation is that it's going to be more challenging.
Yeah.
And it seems like, how do you, if you're going to plug the hole with a 3rd brick, how do you get the brick there?
Well,
I mean, does that inevitably involve your hand a half an inch away from the barrel?
Sure. So there, you can make other contraptions that we've considered, like a reach, sort of like the things that you use to reach really far away and just grab it and put it there. But the simplest design is that, when I'll show you the picture. When you can walk right next to the barrel, you can sort of stand right here, and you're not feeling any heat. So you can, if you just drop in the brick, you're technically not feeling any heat over you. Whereas even with the sheet metal design, you're directly in front of the channel that does have the heat coming out of it, if that makes any sense.
Yeah, I'm just surprised that you're getting so much heat out of the channel as opposed to just radiating out the side of the barrel.
Comparatively,
I think a lot of it is smoke too that Jess is talking about. A lot of smoke comes out of the channels.
and comparatively, remember that it was all on bricks before, so all the heat was radiating out of the bottom, and that was going right to their feet, to their ankles and whatnot. And
because if it's just as easy for them to bring 9 bricks as 6 bricks, then the easiest way to tell them how wide the hole should be is that it should be a brick wide.
Yeah.
Right. And just measure it with the bricks you're about to use to plug it. But if you can't get there to put the brick in, then that whole efficiency is not worth it.
Right. So that's why, for the time being, we still prefer the solution with the metal seal.
So, Jess, you tested with the hot barrel, putting the bricks in? And didn't
not with the hot
experience
barrel,
heat?
no.
No, we've time tested that.
Okay,
Yeah.
because I question that you wouldn't be exposed to heat by
Right.
putting a brick in.
In our video, I was significantly close with the sheet metal, and and I had to be over the channel, so I can only imagine them being on the side of it where the smoke isn't rising would be better. But that is actually what we're going to be testing on Monday, which is we're going to have we're going to do 2 barrels, and we're going to be testing the thermometer readings like along the different points around the barrel at different distances.
Or are you converging
No,
to
we'll
one?
be testing where it's hottest. So if there is a really significant difference between right above the channel and here, then we know that this is like a safer area or a better area for them to work with.
How do you test that?
There's a like high resolution thermometer that we're borrowing from 2671 and from Harvard Lardo. And
Wait, is it one of the like the infrared gun thermometers?
No,
Or-
no, it's just
okay.
like the ambient temperature one.
Yeah.
So is that measuring air temperature or sensed temperature on skin or surface?
No, not on skin or surface, just like you can just hold it. So air temperature, like ambient temperature.
Metallic.
I'm not sure, I haven't looked at it, but that's what the description says. There's a surface one that depends on like the surface roughness and the surface like change of temperature too, right, and the material. But this one is just supposed to be able to hold it up.
I mean, if you have something metallic and you have a source most likely radiating to it, you're not going to measure any heat off of that because the emittance of the metal is going to be so low, or the absorbance of the thermocouple is going to be so low. So when you say you have smoke coming out of it, just to kind of continue, so smoke's coming out of the channels at the bottom, right? So is that happening the entire time or only after you seal the top?
Only after you seal the top.
Is there any reason you can't seal the bottom first and then seal the top?
The top is just more of a, like, there's actually fire coming out of it, and if the wind changes direction really quickly, then if you're standing close to the barrel, you could actually be pretty close to the open flame. So the way the barrel is sealed now is with the top first, and then kicking out the bricks afterwards. So we've just stuck with that.
That might be a stability, right?
Yeah. Yeah.
But you don't want this thing wiggling back and forth when the top is open because maybe some embers can come flying out or something like that. But if you're not wiggling the barrel, maybe you can just seal the bottom first and smoke won't come billowing out of the bottom and then you can seal the top.
I think because like smoke is still coming out at like kind of like eye level when the top is open. So our intuition tells us to seal the top first before we try to
Well, maybe that's another experiment.
Yeah.
Absolutely.
So that's a worthwhile experiment. Yeah, and the point about, measuring heat is complicated, and so because it's coming at you in 2 different ways, and your measurement devices might only measure one or the other of those ways, and you might want to try a bunch of different ways. I mean, it's because what you're going to be getting is radiant heat.
Mm-hmm.
As bogus as this sounds, you might actually get a more useful measurement by yeah, either how hot does it feel, or if you want to get some kind of integrated measurement, you buy 3 cantaloupes, because those at least look like human beings and will absorb radiated heat about the same way where you put them around the thing and then measure how hot they get 15 minutes later. You've got to do something, but you need an absorber that looks like a person, looks like skin, because it's the metal's going to reflect all the radiant heat.
Sure.
So the thermocouple won't see it.
So another way to do that is to just wrap half or a third of the barrel vertically in tin foil and use some sort of metallic wire to strap the tin foil to like 1/3 of the barrel or half the barrel, and that will act as a huge radiation shield. So if you want to, that would just tell you if the heat is coming from hot air coming out from the bottom or from radiation off the barrel, and then you would know actually what your problem is.
Sure.
So that would be a good test.
Any other comments, especially on the sheet metal seal and whatnot?
I just wouldn't bank on the women being able to do a test early next week as part of your critical path.
Sure. Lindsay did already say that they wanted to do a burn. That's why we are not counting on it, but hope that it can happen. But
yeah,
you're right.
absolutely. But I think you should try to make that happen, but also if it takes them a week to make it happen, be able to work with that too.
One thing I noticed when you were showing the video of you sliding the covers on over next to Kresge, it looked like it would be useful to have a way to pick up the front of the sheet with a simple stick. And so I think you could do that simply by putting another block in the back, so you had another lever point So you can
Just-
push the stick in here and effectively pick it up like that.
Hmm.
Just slide it over the bricks because it looks like there's a little
Yeah,
tough sliding over the grass.
it's a good idea.
Yeah. That would need to be as far back towards the back edge.
Yeah, one of our designs actually after this experiment was to sort of like make a hole insert where you could put in the wood, but it was mostly for like more leverage points.
Yeah, and then on the flip side, trying to minimize how much metal is used is also important
Yeah.
because it's expensive.
So in the design that Jessica just referenced, you take your sheet and it would have to be thinner than this, and then you could cut it like here and then there and leave a certain point there and just bend those two edges together and just fold them once on top.
Yeah, and I also wonder like if the bricks are decently sealed against the grass, if you could make your devices significantly smaller to just cover the hole and not the whole area.
Yeah.
Do you end up putting sand all the way around the edge of the barrel?
Yeah. Yeah.
So I can't forward to it, but
If you exit out of PowerPoint, you might be able to load it in QuickTime or whatever.
Video too.
Yeah, it's totally like you don't want to be rocking the barrel, but we don't like they did a different order than we do in the video. So we normally just put the lid on top, but then we drop it down before we put the sand, so you don't have sand falling off when you're rocking it. So you don't like that's why I said like they should try it because you don't have to put the lid on top first.
What are you looking for, Jessica?
just to show them.
Oh, the ceiling? The ceiling.
Yeah, he asked for what the final thing looked like.
Right. So it looks kind of like that.
And what happened here was that the grass is a lot fluffier here than in Nicaragua. Like over there, it's kind of burnt out, kind of dry, kind of just not that much grass. And so we know that like there won't be that much like air holes through the grass that we'll have to seal sand all the way around excessively like that. Any other questions or thoughts or?
How much harder is the light from the water? Now that you have a channel instead of just pretty bricks.
We didn't think it was really a problem in our experimentation. It didn't, like you can still have like strands of the biomass come out through the channels and then just light them right there. And in fact, it may even be easier because there's no wind passing through.
Yeah.
So it didn't take us that long.
It's probably either the same or easier than the current method.
On Emilio's clock, it was 14 seconds, which is more or less what it took us with other. Great, thank you.
Thanks.
So, hello everyone, we're Grupo Phoenix. Well, we're the other part of Grupo Phoenix. We all traveled together, but we spent into two projects. I'm Juan.
I would wait until they're done or convince them that
We're pretty awesome. You should listen.
You have electricity too.
Cool.
So, I'm Juan.
I'm Liz.
I'm Sid.
And our mentors are Amelia and Steve. So I'll just start with. Currently, we're working with the cooperative in Sabana Grande that makes they make solar cells. They make solar panels, and for they use them for home power and also for as individual cell phone chargers. Currently, these are the large solar panels that they make. They're 60 watts. You can see each solar cell is donated, and all the solar cells that are used are donated, and they're about 500 cells per box.
Well, they do have to be bought though. They're about a
Yeah.
dollar
Oh,
per cell.
sorry. They're bought for a lower price because they're
Rejects.
They're rejects from the factory here in the U.S. The problem is that they're really fragile, and a lot of them break on the shipping there. And so right now they're also making solar cell phone chargers. But to make the solar cell phone chargers, they need to cut each individual cell so they can get a high enough voltage, but still have a small enough solar panel that it's transportable. Yeah, so this is just this is the landscape of the place where we are. We can see there is no grid in a lot of the houses, but a lot of people still have cell phones, and so some of them have to walk up to 2 or 3 kilometers to charge their cell phones, and they pay 10 cordoas, which is about 50 cents per charge. So that is how we want to, I guess, help the project. This is an example of a Chinese-made cell phone charger that they have used. As you can see, it charges, and it comes with an extra battery, and it charges the extra battery in that device. But this only fits one only fits Nokia cell phones, and 2 is just imported. So this is not we don't think it's really helping the job market in the area.
It costs $20.
Oh, it also costs $20. So our goal is to make. So this is why I guess this is why we want to make a cell phone charger. So we want to make one that is can hopefully compete with this. Not obviously in like initial manufacturing costs, but at least in like end costs to their own manufacturing costs. Can reduce their time. Currently, it takes them 24 hours to make the small cell phone chargers, and it can also it can also be transportable and charge their cell phones and charge all the different types of cell phones that they have.
Okay, so as Kwan said, basically the solar cells output 0.5 volts each, and this is your original cell. The way they do it right now is that they cut up these cells into 4 parts across like that, and then connect them in series so you can step up your voltage. Unfortunately, what ends up happening is when you're cutting these cells, as one mentioned, they're very fragile, so you end up wasting a lot of your cells, and that actually is the largest, like they spend the most amount of their money in cutting the cells and then using the silicone, but we'll get into that later. So we decided that it would be helpful if they could just use the original cells instead of cutting them. And so we thought that if they just connected 3 of these cells in series, you could go up to 1.5 volts, which is about like a normal pencil cell. And then we thought we would just step up that voltage to 5 volts, which is what a cell phone charger uses. To do that, we bought, so this is the circuitry that we're using. So essentially, like a lot of, I mean, we couldn't actually make the step up. We tried, but we failed. So we decided to just buy it like off the shelf. And so this is how our breadboard looks. Essentially, this would be your input right here. And this would be 1.5 DC input, and then you'd have a 5 volt DC output coming in from here. And basically, your solar cells would be connected. So your solar cells are here. This little thing fits into this depression right here. And then, so your panels are connected in series. You have 2 wires connecting to these terminals. It steps up to 5 volts and goes out to connect to this thing. This thing then goes into your Nokia / whatever phone you have, and then charges your phone. Is the video?
Yeah, it's the next one. Make sure my volume's on now.
Yeah, so we kind of like made a video.
All right.
Okay, so we're switching on the light. So 3 cells right here. And now we're gonna measure the voltage outputted by the solar cells. It's 1.6 volts. That's good. We're now gonna measure the voltage outputted after we step up.
Can you guys hear that at all, or is it?
So that's good.
Okay.
Now Juan's gonna plug in the cell phone. Okay, and it says charging. It's 3.8.
Which is the voltage across the battery, so it makes sense that when it's plugged in, it's 3.8 volts instead of 5.
And yeah, so that's basically like the works like. Yeah, I think that's pretty much what it looks like.
Yeah. And then we've also been talking to the community. We're hoping we can talk to them on the phone soon. This week they haven't really been in contact because it's Holy Week. But we sent them this in Spanish and some other instructions about kind of what we've been working on, so we can hope to get their feedback. This is our kind of looks like model. You saw how Sid kind of can put the stuff into this indentation here. so that when it's not in use or when it's noon, it can be completely flat. This also protects all of the circuitry from the like rain and that kind of thing. There could be notches added to the sides so that, for instance, you could make it lower by lowering these, and it could be like that and stay still. And it's also just something they can really simply make. They also make other things with wood in the same center, so they have all the materials. It's pretty low cost, and you can add, we have a hole here for security, you can see in the picture, so that if they want to kind of like tie it up and lock it to something while it's charging, they can do that. It's pretty portable, but it's also like not so small that someone can just stick it in their pocket and run away with it. It's adjustable and just easy for them to make, so we're hoping that they like it. They can easily change the looks like design as well. Most of how we're trying to help them is the axe like, because they're pretty capable of coming up with things like this themselves, but this is just kind of our suggestion. We've also been talking with some other people who are working on the other aspects of the solar panels, like trying to make the application of the glass on top easier and things like that. So other people have that part covered, so we're focusing a lot on just making it actually be able to charge a cell phone. And what we're looking to do next is, like right now it's on the breadboard, and it's definitely like if you handed this to a customer and we're like, don't break it, like something's going to come out and then they won't know what to do with it. So we have to make it more kind of able to be actually given to somebody and not break. So more durable, I guess. We need to be able to make it easy to explain, so that because we might not have anybody down there showing them, they can still learn how to do it. They have a mechanic, an engineer who's been trained and should know how to put this together reasonably well, and he's definitely better at soldering than we are. So it should be doable. Thank you.
Yeah, and like to be clear, like this is just a model of, this is actually going to be a solar panel. Like this is not wood, in case people were kind of confused. this is the solar panel, but since our project focuses on like converting the voltage to a cell phone charging voltage, we decided to just like go with this just to show you guys how it's going to look when the solar panel is in fact installed. Yeah, that's pretty much it. Three uncut.
Yeah.
Pretty much. Yeah.
What's the cost of your circuitry? You said you ended up buying.
So we estimate, so like right now we bought 5 of each. If you buy like large scale, like wholesale, I think this thing should cost about $4. Yeah. Like this entire.
It cost us like
thing.
$6.
This is about $6 for us, but I think it should cost $4. And then so the connectors are actually more expensive, but that's because, so there are 2 ways to do it. Either you buy the whole thing, cut it off, but that doesn't make any sense, right? So when we looked it up online, you can buy like about 10 of them for $7. But there are probably cheaper ways to buy them. Maybe if we contacted the company, asked them about it. We're still deciding how to get them for cheap. But we can definitely, I think this should be about $1 max, like if you just buy it. So. And
then when you add in their like the time they'll use, like it probably will take them about 8 hours now because they won't have to cut cells. So that'll add another $4 or something, because they like getting paid about 50 cents an hour, I think. So it'll definitely be able to compete with the current one, no problem.
Yeah. Are there any questions?
Sorry?
I'm sorry, yeah, I didn't catch that.
Like, if you have a panel outside and it brings the flash rain.
So basically the concept, the reason we decided to put in the depression underneath was that like if it did rain, it wouldn't be immediately affected. That being said, like this isn't going to protect it against, like if you like leave it out in the rain, it's not going to protected. So I guess the concept is that you leave it out only when it's bright, but if it suddenly starts to rain, it'll give you a certain amount of protection against it before you can, take it back in.
And the solar cells themselves, to be clear, are not going to be just like bare
the
way
yeah.
we had them.
This is a panel.
Like they'll still do the process of with like a silicone and glass on top, because that's necessary. You can't. I mean, the cells get damaged if you don't encapsulate them.
Right. I mean, just to be clear, I realized we didn't explain like how the panel looks. The way the panel looks is that like you have the 3 solar cells in series, which are then encapsulated in silicone. You have an aluminum frame. Yeah. Sorry. So you have like an aluminum frame. You have these cells in series, and they're encapsulated by silicone. You then you put pressure on a glass frame on top of it and leave it to, like set. And then you have like a plastic sheet underneath. So this is basically waterproof. And this is what we're talking about will be here.
Because these are the kinds of panels that they stick on their roofs and
Right.
use for power.
Except like in our case, you'd have only 3 cells as opposed to.
Yeah, so it's a lot less time. A lot of the problems with the big ones is when you encapsulate it, you have to push it down and make sure that there's no air bubbles, and it's really hard on a big panel to make sure there's no bubbles, but on the smaller ones, it's mostly the cutting that they said they really need to get rid of, so that's what our goal was.
Yeah, I mean the goal basically, like Liz said, is to eliminate cutting the cells, because that's a pain.
It's a pain, and they break, they said, like, you know, if they have 5 cells, they'll break 3 of them, or,
Yeah.
like, and so they won't break these because they're just full cells.
Right.
But have you tried in lab pointing that halogen light at the solar cell and actually fully charging the phone? Like,
Yeah,
have you-
yeah,
have you
this
seen
was
the
like
charge-
yesterday that we got it.
The
Yeah.
efficiency on that is so horrifying as
Yeah.
to be, I mean, it's like
Yeah, it's fair.
0.01%. I mean, it's like 10 amps, 15 amps at 120 volts to get like a milliwatt into the phone, which is crazy, but you should try it.
Yeah, we actually got, like, the video we showed you was yesterday, so we're probably going to try that over the weekend.
Yeah, you should just set it, I mean, find a phone that'll actually give you like some kind of decent readout of how charged it is.
Right.
Yeah.
And run it for, you know, half an hour and see how much the charge improves over a half an hour,
Yeah.
or take out the battery, measure the voltage on the cell at a couple different times or something.
Definitely.
We did a rough calculation based on it should have about 100 milliamp current and like how long that should take, and it'll be longer than the China one. The China one's about 5 hours, and this hopefully will be like 7 or 8 hours, but we have not tested this, so that could be a big problem. We have to figure that out.
Because you may just find that you need to have storage in your thing. If there's not enough current coming out of that thing to charge in real time, you may have to add a battery to that so that you can store a little bit and then charge your phone off the storage.
And we've also been testing the voltage necessary to actually get enough voltage to like, so we can get enough voltage that it can be stepped up to 5 volts. And right now we're getting that is 1.2 volts is the minimum. According to the circuit, we should be able to step up to 5 volts using only 0.7 volts. So we're gonna keep trying that.
But it also shouldn't be much of a problem because in Nicaraguan sun, like, it is a volt and a half. Like, it would have to be like sunset for it to be that low, and who's charging their solar cell phone at that hour, really?
Yeah, but I mean, yeah, so we're definitely going to try that though, just try and charge the cell phone. Part of our initial plan was actually to have a separate energy storage device, like, in our system, but we decided that that would, like, increase costs, and so we thought that if we could do it without that, yeah, so, but yeah, that's always a possibility though, yeah.
Any feedback from Mauro or others at Group of Phoenix yet?
We really need to talk to them. Like, they're not very good at getting back to us.
Okay, so I would encourage you to use the phone next
Yeah.
week.
Yeah,
We want to
we're
talk
probably
to
going
them
to just
next
call
week.
them.
We have a lot of questions, and a conversation will be really helpful.
Yeah.
So how many non-Nokia phones did you see when you were there?
We only actually saw 2 kinds of cell phones. We saw Nokia and a ZTE phone. And a ZTE phone can be charged in a similar way. It's the same voltage input. Yeah, it's a different connector. We could also do this with a USB charger, but the Nokia phone can't be charged via USB, so we just use that. We're waiting. Lindsay, the woman who's the liaison that the other group was talking about, said that she has like a spreadsheet with what kind of cell phones everyone has, but we're trying to get that from her.
Right.
But we asked a lot of people, and those are the only 2 cell phones we found.
Right, so I mean, right now these are the 2 connectors we have. This one charges the
Yeah.
Nokia, and then this one's a USB charger. So, any more questions? Okay. Well, thank you.
Thanks.
As we speak, we're actually going to pass around the little Ziploc bags of the experiments we did with the rice. And the NGO that we worked with was called Asa Prosar, and we are actually part of the class that went to El Salvador and not Nicaragua. We worked in a community called La Magdalena in El Salvador, and the NGO is currently introducing rice cultivation in the community, both to be used as a source of income and also as nutrition. And in order for the rice to be ready for consumption, it needs to be processed, and the process involves threshing and dehusking. And current methods of dehusking are very time and money intensive. They usually involve a 2 to 3 hour bus ride to a mill where the rice can be processed, and it costs about $3 to $4, we found out, which is about a daily salary. So our design challenge is to develop a method that's for more local, faster, and cheaper way of dehusking rice. The two most important project specifications that we focused on were the efficiency, which refers to the amount of rice that's successfully dehusked, and also how gentle the process is, meaning we wanted to minimize the amount of rice that's broken or cut in half. And some of the other specifications we looked at were safety, affordability, of course, durability, and also aesthetics. We approached the problem by brainstorming. We researched some existing technologies that people use in regions that rice is grown. Some of them are more simple, some of them involve heavy machinery. What we concluded, though, is that all of these technologies use friction in order to get the husk from the rice. And it's a matter of adjusting the amount of friction we have in order to get the husk off, but not break the rice grain. And some of the ideas we ran through were pepper grinder, where we have cylinders rotating together, rubbing together plates that can be made from different materials, mortar and pestle idea, which is used, but it's a lot more energy intensive and not as efficient. And also the molino, which is a corn mill that's currently used in El Salvador to grain corn. And that's basically two circular plates that rub together, and that's what we actually have over there.
So Amy Smith actually had visited this community before we had, and she had looked at this molina and inserted a black inner tube in between the two metal parts. So we used that kind of as our standard when we were looking at how we could go about improving this process. So we used this pew chart with these attributes to kind of figure out which one would be the most feasible to do this semester, and which one would be the most efficient for the community to use overall. In the end, we chose to modify the existing molino by inserting a different material in between the plates. Right now we have the two leather inserts in there. So we kind of just add like a circular insert in between them. The advantages of using the molino is that our community partner, Asa Prosar, is actually distributing the molinos to the community to use for corn, to make cornmeal, to grind yucca, so it's very multifunctional for them. And although the cost is $20, Asa Prosar is funding this distribution to the communities. And as it is now, either one family will use it or a whole community will use it, so it's available to a lot of people. It's pretty durable, the metal is pretty rigid, and it's not labor intensive, it's just a hand crank that you use. A few of the challenges with the molino, though, is that when you just do it without any insert, it cracks or breaks the rice, so people don't really necessarily want broken rice. And it wears the material down if you put something in there. We kind of need a durable material that will withstand this turning. So we decided upon 5 different materials that we wanted to test, and we looked at leather, rubber, metal, wood, and fabric, and based on those we looked at the cost, residue, durability, and availability of those. We brought back leather and rubber from El Salvador, so we actually could use stuff that was available in those communities. And Missy will talk to you about what we found.
So we did quite a few experiments where the main variables that we were really testing were what type of material that we wanted to use, and then also how many turns of the molino that we were going to do. So first, to just highlight the main steps of the experiments that we did. First, we inserted the material, and then in order to be able to accurately measure how much space there actually existed in between the sides of the molino and the insert, we tightened it as far as we could once we inserted the material, and then we measured it from the number of turns out. So how much we actually loosened it from the most tight position. And then we used the same amount of rice for each experiment, 50 grams, and we ran it through, and once it had gone through the molino, we sifted it through to get rid of the really crushed pieces, and then we winnowed it, so essentially just tossing the rice up so the air will catch it and blow the husks away so you can get rid of the husks. And then we separated the rice into four main components, being the rice that was still husked, the rice that was whole, the rice that was crushed or broken, and then also if there were any husks left as well. And then we noted, and you'll see the bags themselves are labeled as they're going, passing around how many turns that it took, and then the weight of the still husked rice, the weight of the husked rice, and if it was in pieces and such. So this is we won't like this picture, is a picture of the rice that is still husked, a whole grain of dehusked rice, a broken grain, and then some of the particles that we used to sift through to get rid of. And so one of the experiments we used was the honeycomb rubber, is what we called it. Picture's kind of self-explanatory why we called it that. But so we did a couple experiments with this, and you can see in the pictures that we have whether it's kind of hard to see from these pictures, but once we've separated it through how much of the rice is still husked, how much of the rice has been dehusked based on the number of turns. What we noted about the rubber, though, is that we weren't very sure how hazardous the residue that might end up on the rice would be, because it's not an organic material. We also noted that this rubber costs about $6 per square foot, so it's not too expensive. We decided to flip that rubber around and decided to test it with the different textures. And the same thing happens with this rubber. Again, it's not organic. So we did a quick little data sheet based on the number of turns and the mass we started with, and then the mass that was broken, and just to get an idea. Then we continued on with leather, which was the kind, since it's organic and a little bit cheaper than the rubber, made us feel a little bit better, is the one we kind of preferred. And it's very readily tested, but we were trying to decide how many layers of the leather we should put. So, alright. So as we did the experiments with the leather, sometimes we processed it through twice, sometimes we did different number of turns with different layers, and you can see most of them are relatively the same, some are a little bit better, but ultimately we decided that the material wasn't the biggest part, but we still decided to test with duct tape, which we found unfortunately wore away relatively quickly, and then we tried for the heck of it a flat sheet metal surface, and essentially that was a disaster. So I'll hand it over to Benji.
So one of the reasons that we decided to go against the flat metal was because the rice wasn't actually fed into the molino. The way that the back plate is designed and shaped, it feeds in the rice, and so we decided to just focus on the one side on the back side of the molino and just adding the material there. So as you can see, like, we have a lot of the tests, and we did a lot of tests, but actually there was no conclusive, like, awesome material that was way better at husking the rice than the others. And so basically we said, okay, well, we noticed that the most important variable for deciding that was the number of turns away from tightening it. And so we said, well, we still have to decide on a material, so we wanted to optimize how much rice was broken, and also just think about the robustness and the availability of the material. And so we decided on choosing leather because its availability and because it is organic, it's much safer. And so we did a couple more exploratory tests with the leather and trying to decide how soft we wanted to make the leather effectively, like how it interacts with the rice. And so we tried with 2 pieces of leather glued together and then 3 pieces together, and unsurprisingly, we actually found that they were very similar as well. So we decided on going with 2 pieces of leather rather than the 3 because it's less material, it's less expensive. And so going forward, we're going to be optimizing that sort of 2-layer process, or how we're going to be gluing those together, what type of glue, or if we're going to sew them together because the glue might not be available. And so we'll be looking at those sort of details of that leather material, but also we wanted to look at the process of how it's being put through the mill. So not only changing the material, but also thinking, well, if we change the number of turns to, say 3 times more than usual, and then going through it twice, does that change the results at all? Like, is it more gentle with the rice if you process through it twice while husking more of the material? So we'll be looking at that, or if we can do anything to the rice prior to actually running it through the mill that would make it more effective for dehusking it. So that's about it. If you guys have any questions, we can also show how this is working so far too.
One reason was for explaining it to community partners. It's a lot easier to say 6 turns from as tight as you can tighten it, as opposed to 3 millimeters in between, because we don't want to use exact measurements for that. And also, kind of gave us using different materials, it gave us a lot of flexibility with how much work we had in between. So you guys kind of give a standard overall.
So this is the trim we're talking about. So we're trimming it. So let's see. This is as far as I can go. And then, how many turns should we do? 3. So 1, 2, 3 turns.
Maybe we could do a little more so it's easier afterwards.
Well,
but yeah.
4. And then you go. And it takes a little bit of, like the first few turns and the last few turns are
very awkward.
yeah, a little bit difficult. It takes a while for it to start because it just needs some amount of rice to be in there.
See, like we did, but just from the little bit that has come out already, there's a lot of broken pieces. So like with this setup, we've done it at like 4, 5, 6 turns. Just because we found that like having the rice not actually dehusked.
Oh, it's
and,
getting against this.
But we'd rather have rice that's not dehusked as opposed to like a lot of broken pieces.
It takes a few people to do it.
I'm not sure if you guys also saw the bag that was just broken. So basically, it still husks it without this material, but it's actually much more effective at this. From a shoe place, right?
Do you know how they made it? Because leather tanning, I mean, that leather could be the most toxic thing you have.
Yeah.
Conceivably. I mean, like one of the things that is used in leather tanning is like chromium sulfate as the tanning agent. So like it's just worth finding out. I mean, another option is tannin, which comes from oak trees. I'm guessing we have a lot of oak trees in El Salvador, but yeah, it's worth finding out. Because it would be sad to poison everybody.
Right.
It's hard to get invited back after. Well, they can't invite you back if they're all dead.
We've been waiting for them to respond to questions, but some of the questions that we've been trying to get answers to are like how many people may need how many people can use it? Would it be a family or whole community? And how much rice do they consume? How much rice can they grow? And I think it's gonna be important for us to know in terms of the material and how durable the material is. And does each family have a piece of this leather, or is it permanently attached to the mullion? And so there's a lot of questions that we're still.
I just wouldn't take for granted what is and isn't toxic,
Right.
based on because the rubber could be
Yeah.
fine for all we know, and the leather could be
Yeah, we're not sure.
poisonous. And if what comes off is stuff that you can wash off, then it's not the end of the world.
Well, the problem with the inner tube was that it was leaving like a black residue on the.
Right, yeah.
So
if it's like
they were
marking
like,
with a crayon
like,
on
there's
each
black
one,
on
yeah.
here, we don't wanna use
But if
it.
there's like, a little bit of rubber dust that comes off, but it's not adhering to anything, then you can wash it off, and it might.
Your yellow rubber.
Yeah. So it's just worth actually finding out what chemicals are actually present, because it might be that you could eat a loaf of that rubber and you'd be fine, but if you chew on the leather for a little bit, you get sick.
It's just hard to control that. You know what I mean? Like the shops will be doing their different. I don't know.
Yeah.
Well, I think it's worth figuring out. Like worst case scenario, this leather is tanned with whatever chemicals Steve just mentioned.
Right.
Is that something that's going to get absorbed into the rice, or something that's going to be washed off during processing? If it's going to get absorbed, maybe we need to knock this leather out as a contender and find something similar, because it seemed like different materials all seem to work basically the same, and so would an old T-shirt work just as well or something? I don't know.
How did fabric work? Did you try?
Yeah, so that's the reason we did the duct tape, was like not as an actual sort of design, but just to see how long it lasts, because it is like generally wear resistant.
But it does wear, and like
But it wears
we
out very
tried
quickly.
this foam material, and that like you can see that.
Yeah, with
after
50
a
grams,
few
with the 50,
turns.
with even running like this much of 50 grams with the duct tape, you could tell that it was worn. And like they actually do tests with between denim and leather, like for motorcycles, and like they simulate someone falling down, and like the leather lasts for 90 feet of dragging, while denim lasts for 5.
Wow.
So, and denim is like very durable, right? Like
The inside, I don't know if Benji showed you, but the inside of these.
Can you
Oh yeah. I mean, it's like you're trying to grind sandpaper.
Yeah,
It's going
so
to wreck
it's like
whatever you put in.
both sides are ridged. So.
That's the reason why that thing's made out of metal.
Yeah. So that's why we were looking at doing flat metal, so that was more durable. But like I mentioned, we need the design on the inner part to pull the rice out. Otherwise, it's just like two pieces grinding against each other, no rice.
And so even if you made the inner hole, the metal piece that goes on this side, did you make the inner hole big enough so that the rice could come out through?
Yeah. So it needs this cutting in, the dimension. Like it can't actually just be a flat surface, no matter how big the hole is, because the rice isn't allowed to like feed into it.
These ridges like wear the material down a lot. And it's on both sides of this.
Have you found? I didn't go look. I was too busy looking up how you tan leather while you were talking. But but there are all over YouTube. There are videos of like how manufacturing processes happen. Usually they're put up by the people who build the equipment. And I'm curious how they actually how rice actually gets husked.
Yeah. So they do it. They do it with like rollers, basically, like rubber rollers a lot of times. Which is it's a totally different geometry that we're dealing with. But like Beulah said, it's like the friction.
Yeah, I just wonder if there's pieces of that you can steal.
Yeah.
There's like if that's too coarse, but a flat plate with a single slot cut in it would get you like if you had grooves cut in it that happened to be about the right size for a grain of rice or something, it would help you out. But I don't know. I'm just wondering if there are tricks.
This might be too far out, but what about like a tumbling process instead of a grinding process?
Yeah, the moringa. There's a team also doing moringa seed husking in D-Lab design, I believe. But moringa is actually very soft, and it doesn't end up getting damaged by the tumblers. Whereas the husks are actually pretty soft, and the rice is hard. So if there were tumblers, just from looking at it, the rice would probably get more crushed, whereas the husks probably wouldn't really as much.
Because we found that the soft materials really like give and allow the husk to come off with the friction, but not damage the rice as much. So we try to push for softer as opposed to kind of like that hitting.
What's wrong with broken rice?
That's something that we
Sell it for
actually
as much.
that we wanted to ask the community.
I bet it gets mushy. It probably gets more mushy than regular.
Well, part of the reason they want to use like this as a tool in their community is they want to sell rice too. So I would assume we haven't been in contact really with our community partner. They haven't gotten back to us, but we would assume that they'd want to sell whole grains as opposed to.
One question, I think I mentioned this last time I saw you guys, one question you might want to ask is what their expectations are for broken rice. If they already, from the mill, if they get 25% broken rice already and they just expect that to
Yeah, so I would get on the phone
Yeah.
next week.
We can try to do that.
And hopefully we can reach them. If you whatever material you end up with, whether it's leather or something else, figuring out just how long it does last, so how many grams you can process before you need to replace it, and then getting like a both for your users so that they know we should be replacing it this often, and also so you can get a cost estimate for like we're gonna in a year, you know, or this many tons of rice, we're gonna need this much leather or whatever it is. It will be useful.
Did you bring the rice back from El Salvador?
No.
Or is it from like a farm nearby? Where's the rice come from?
It is from a farm in
Arkansas.
Texas. But, I mean, from comparisons, they are very similar.
Yeah, well, nobody's going to let you bring a sack of unhusked rice
Yeah.
back from El Salvador. I mean, if you did it hidden in a vault up sock.
All right, thanks you guys.